Types of polymerization reactions. Addition polymerization or chain growth polymerization. This mode of polymerization can take place through the formation of either free radicals or ionic species. However, the free radical governed addition or chain growth polymerization is the most common mode. Free radical mechanism. Chain growth polymerization usually has the following steps. Chain initiation, usually by means of an initiator which starts the chemical process. Typically, initiators include any organic compound with a labile group, example, azo, N, disulfide, S, or peroxide, O. Two examples are benzoyl peroxide and AIBN, azobis-isobutyronitrile. The polymerization of ethene to polythene takes place by heating or exposing to light a mixture of ethene with a small amount of benzoyl peroxide initiator. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating a new and larger free radical. This step is called chain initiating step. As this radical reacts with another molecule of ethene, another bigger sized radical is formed. Chain propagation. The repetition of this sequence with new and bigger radicals carries the reaction forward, and the step is termed as chain propagating step. Chain termination. It occurs either by combination or disproportionation, when the free radical thus formed reacts with another free radical to form the polymerized product. This step is called the chain terminating step. Preparation of some important addition polymers. Low density polythene. Under high pressure of 1000 to 2000 atmospheres at a temperature of 350 K to 570 K in the presence of traces of dioxygen or a peroxide initiator catalyst, ethene polymerizes to give low density polythene LDP. It is used as insulator of electric wires and for manufacture of squeeze bottles, toys, and flexible pipes. High density polythene. It is an addition polymer. It is formed by polymerization of ethene, which takes place in a hydrocarbon solvent in the presence of a catalyst such as triethyl aluminum and titanium tetrachloride, Ziegler-Natta catalyst at a temperature of 333 K to 343 K and under a pressure of 6 to 7 atmospheres. High density polythene HDP has a high density due to close packing. It is chemically inert, tough and hard. It is used for manufacturing buckets, dustbins, bottles, pipes, etc. Polytetrafluoroethene Teflon. PTFE is used as a non-stick coating for pans and other cookware. It is very non-reactive, partly because of the strength of carbon-fluorine bonds, and so it is often used in containers and pipe work for reactive and corrosive chemicals. PTFE is produced by free radical polymerization of tetrafluoroethylene. The net equation is NCF2 double bond CF2 tetrafluoroethene in the presence of catalyst and high pressure gives CF2CF2 whole N Teflon. Polyacrylonitrile PAN, a synthetic resin prepared by the polymerization of acrylonitrile. NCH2 CHCN acrylonitrile polymerization peroxide catalyst gives CH2CH whole N polyacrylonitrile. It is a hard, rigid thermoplastic material that is resistant to most solvents and chemicals, slow to burn, and of low permeability to gases. Condensation polymerization or step growth polymerization. Condensation polymers are formed when bifunctional or trifunctional monomers react to form a long-chain polymer molecule. Small molecules such as water, alcohol, hydrogen chloride, etc. are eliminated during the reaction. In these reactions, the product of each step is again a bifunctional species. Since each step produces a distinct species and is independent of each other, this process is also called as step growth polymerization. Terylene or dacron are formed by the interaction of ethylene glycol and terephthalic acid. Some important condensation polymerization reactions. Polyamides are polymers which contain repeating amide CONH linkages. Proteins are examples of naturally occurring polyamides. The general method of preparation consists of the condensation polymerization of diamines with dicarboxylic acids. Preparation of nylons. Nylon 6,6 is prepared by the condensation polymerization of hexamethylene diamine with adipic acid under high pressure and at high temperature. The properties of the polyamides, nylons, which include high strength, abrasion resistance, and resilience, make them very important in the manufacture of clothing and carpets. Nylon 6. It is obtained by heating caprolactam with water at a high temperature. Nylon 6 is used for the manufacture of tire cords, fabrics, and ropes. Polyesters. Polyesters are polymers formed from a dicarboxylic acid and a diol. They have many uses depending on how they have been produced and the resulting orientation of the polymer chains. Dacron or terylene is an example of polyesters. It is manufactured by heating a mixture of ethylene glycol and terephthalic acid at 420 to 460 K in the presence of zinc acetate antimony trioxide catalyst. Polyesters are extremely important polymers. Their most familiar applications are in clothing, food packaging, and plastic water and carbonated soft drink bottles. Terylene is also as glass reinforcing materials in safety helmets, etc. Phenol formaldehyde polymer, bakelite. It is a thermosetting phenol formaldehyde resin formed from a condensation reaction of phenol with formaldehyde. It was developed by Belgian-born chemist Leo Baekeland in New York in 1907. A mixture of phenol and formaldehyde are allowed to react in the presence of a catalyst. The process involves formation of methylene bridges in ortho, para, or both ortho and para positions. This results first in the formation of linear polymer called novolac and then into cross-linked polymer called phenol formaldehyde resin or bakelite. Bakelite is used in electrical insulators, radio and telephone casings, and such diverse products as kitchenware, jewelry, pipe stems, children's toys, and handles of various utensils. Melamine formaldehyde polymer. Melamine formaldehyde polymer is used by the condensation polymerization of melamine and formaldehyde. It is used in the manufacture of unbreakable crockery. Copolymerization. When two or more different monomers unite together in random sequences or alternating sequences to polymerize, their result is called a copolymer and its process is called copolymerization. The copolymer can be made not only by chain growth polymerization but by step growth polymerization also. For example, a mixture of 1,3-butadiene and styrene can form a copolymer. It is used for the manufacture of auto tires, floor tiles, footwear components, cable insulation, etc. Natural rubber. Natural rubber, also called India rubber, consists of polymers of the organic compound isoprene with minor impurities of other organic compounds plus water. It is also termed as elastomer and has a variety of uses. It is manufactured from rubber latex from the bark of rubber tree. Natural rubber may be considered as a linear polymer of isoprene, 2-methyl-1,3-butadiene, and is also called as cis-1,4-polyisoprene. It can be stretched like a spring and exhibits elastic properties. Vulcanization of rubber. Natural rubber is produced from latex, milky emulsion drawn from the rubber tree or some other plants. When coagulated, latex transforms into soft plastic and sticky substance, crude rubber, which is then vulcanized, cured. Natural rubber is composed of polyisoprene molecules. The process of vulcanization consists of heating a mixture of raw rubber with sulfur and an appropriate additive at a temperature range between 373 K to 415 K. The additive modifies the polymer by forming cross-links, bridges, between individual polymer chains. In the manufacture of tire rubber, 5% of sulfur is used as a cross-linking agent. Synthetic rubbers. Synthetic rubber is made by the polymerization of a variety of petroleum-based monomers. The most common synthetic rubbers are styrene butadiene rubbers, SBR. Other synthetic rubbers are prepared from isoprene, 2-methyl-1,3-butadiene, chloroprene, 2-chloro-1,3-butadiene, and isobutylene, methylpropene with a small percentage of isoprene for cross-linking. Preparation of synthetic rubbers. Neoprene. Neoprene, also called polychloroprene or chloroprene rubber, is synthetic rubber produced by the polymerization of chloropene. It has a high resistance to vegetable and mineral oils. It is used for manufacturing conveyor belts, gaskets, and hoses. Buna N. It is obtained by the copolymerization of 1,3-butadiene and acrylonitrile in the presence of a peroxide catalyst. It is resistant to the action of petrol, lubricating oil, and organic solvents. It is used in making oil seals, tank lining, etc.